Hello students, welcome to the presentation on alkene. First of all, let us see what are the content we are going to learn in this alkene chapter. What is alkene? What is the general formula for alkene? Derive the formula for the first 10 compounds. And what are the IUPAC rules to name alkene? How to derive the IUPAC name of the first 5 compounds. In fact, we are going to see for first 10 compounds. And finally, how to write the structural formula of the first 5 alkene compounds. Now let's see one by one. What is alkene? Alkene is a hydrocarbon, so that means it's a compound containing hydrogen and carbon, in which the carbon-hydrogen ratio should be 1:2. So that means the number of hydrogen should be exactly 2 times that of carbon. So for example, if I give you this formula C3H6, can you guess it is alkene or not? Look at the number of carbons, that is 3. Look at the number of hydrogens, it is 6. So what is the ratio? So this is 1:2. 1:2. So if the ratio between carbon and hydrogen is 1:2, then that hydrocarbon is alkene. Now the second question, what is the general formula for alkene? See, from the rule that the ratio between carbon and hydrogen, we can derive a general formula for alkene. So it is a hydrocarbon containing only carbon and hydrogen. What should be the ratio? It should be CnH2n. So that means what? CnH2n. So n is the number of carbon and 2n is 2 times that of carbon. So therefore always the ratio will be 1:2. So therefore the general formula for alkene is CnH2n. So from this general formula we can derive the molecular formula of alkene having any number of carbons. For example, if the number of carbons are 5 in an alkene, what will be the formula of that particular alkene? So where n is 5, that is C5. So how many hydrogens should be there? It should be exactly 2 times that of carbon. Therefore 2 into 5. Therefore the formula will be C5H10. So like that we can derive the formula for any alkene with any number of carbon atoms. Now let us try to derive the formula of the first 10 alkene compounds. So just now we have learnt the general formula for alkene is CnH2n. So now we have to learn one by one. If the number of carbon is 1 in an alkene, what will be the general formula? C1H2 into number of carbon. So 2 into 1 is 2. Therefore the formula is CH2. But unfortunately this compound cannot exist. A compound with only 1 carbon, that is alkene, cannot exist. I will tell you later why. And if the number of carbons are 2 in any alkene, now what will be its formula? So carbon 2, then how many hydrogen should be there? 2 times that of carbon. Number of carbons are 2 here, therefore 2 into 2 plus 2. Therefore what is the formula? You will get C2. So I am sorry, here it is only exactly 2 times, therefore it is not that plus 2. It's not that plus 2. That is for alkane. For alkene it should be exactly 2 times of that. So 2 into 2 is 4. C2H4 is the formula. Okay, if the number of carbons are 3, now we can go fast. If the number of carbons are 3, then C3H 3 into 2 is 6. Therefore the formula is C3H6. If the number of carbons are 4 in any alkene, then the molecular formula will be C4H. What is the 2 times 4? 8. C4H8. If the number of carbons are 5 in any alkene, the formula will be C5. 2 times 5 is 10. So C5H10. Then here the number of carbons are 6. N is equal to 6. Therefore you will get C6. 2 times 6 is 12. C6H12. If the number of carbons are 7, then the formula will be C7. 2 times 7 is 14. Then number of carbon is 8. Then the formula will be C8. You would have guessed already, 2 times 8 is 16. If the number of carbons are 9, now the formula will be C9, and 2 times 9 is 18. Number of hydrogens are 18. When the number of carbons are 10, the formula will be C10, and 2 times 10 is 20. C10H20. So now we have learned to derive the formula for any alkene with any number of carbons using the general formula. What is the general formula? The general formula is CnH2n. Using this general formula, we can derive any formula. You just try to do it yourself. Now let us move on to the next one. What are the IUPAC rules to name alkene? So again, you know what is IUPAC. It is a union which governs a rule to name any organic compound. So IUPAC is nothing but International Union of Pure and Applied Chemistry. So they frame the rules, and all of us have to follow the same rule to name any organic compound. See, what are the rules to name alkene compound according to IUPAC rules? See here, it is divided into 3 parts. That is, we have to find out the starting name first of all, and second thing we have to find out the middle name, and the last thing we have to find out the end name. Then to get the IUPAC name, we have to combine starting name, middle name and the end name, and we have to get the IUPAC name. Okay, if the number of carbons 1, then the formula will be CH2. That is C1H2. I already told you this compound cannot exist. I'll let you know why when we learn the structural formula. Okay. Now, when the number of carbons are 2, that is when N is equal to 2, what is the formula? C2, then 2 times 2 is 4. So C2H4. So the starting name depends on number of carbon. So when there are 2 carbons, what is the name? Eth. So that already we have learnt. So if the number of carbons are 2, it is eth. If it is 1, meth, 2, eth, 3, prop, 4, bute, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. Already we know this. And here for this alkene, the middle name according to the IUPAC rule is no middle name. See, no middle name, and the end name is ene. Why end name is ene? Because alkene name ends with the last 3 letter is what? Ene. It is ending with ene. That is why the IUPAC name also ending with the same spelling, E-N-E. Therefore, what will be the formula of this compound? Ethene. Starting name is eth, there is no middle name, and the end name is ene, therefore it is ethene. And now find out the name or IUPAC name of the alkene having 3 carbon atoms. If there are 3 carbons, what will be the formula? C3, and 2 times 3 is 6. And if the number of carbons are 3, the starting name is prop. And there is no middle name for alkene, and the end name is ene. You already know why it is ending with ene, because alkene, it is ending with the suffix ene. That is why the IUPAC name also ending with ene. Therefore, name of this compound C3H6 is, see, there are 3 carbons, therefore prop, and the carbon hydrogen ratio is 1:2. Therefore, it is alkene type. Therefore, the end name is ene. When N is equal to 4, that is number of carbons of 4, what will be the formula? C4H8. 2 times 4 is 8. C4H8. Therefore, what is the starting name? Number of carbons are 4 here. Number of carbons are 4 here. Therefore, what is the name of 4 carbons? Bute. And what is the middle name? There is no middle name. The end name is ene, since it belongs to ene type. Therefore, what will be the name of a compound having C4H8 formula? Since it is having 4 carbons, then starting name is bute, there is no middle name, and the end name is ene. C4H8. 4 and 8 is in the ratio of 1:2. therefore it belongs to ene type. It is alkene, therefore the end name is ene. And similarly, when the number of carbons are 5, what will be the general formula? C5H10. Now, what will be the starting name? If the number of carbons are 5, the starting name will be pent. And there is no middle name. The end name is ene, because the carbon hydrogen ratio is 5:10, that is 1:2. Therefore it belongs to alkene type. Therefore name of this compound is 5 carbons, therefore pent. The ratio of carbon and hydrogen is 1:2, therefore pentene. Now let us see for the next 5 compounds. If the number of carbons are 6, what will be the formula? C6. What is 2 times of 6? 12. C6H12. So what will be the starting name? If the number of carbons are 6, the starting name is hex. See here, starting name depends on number of carbons. So here the number of carbons are 6, therefore the name is hex. There is no middle name. And here the carbon hydrogen ratio is 6:12. That is nothing but 1:2. Therefore it belongs to alkene type. Therefore the end name is ene. Therefore what will be the name of this compound? C6H12 hexene. Now, so I think now you can do very fast. When number of carbons are 7, what will be the formula? C7H14. If the number of carbons are 7, what is the name? Hept. There is no name, middle name. And the end name is ene, because the carbon hydrogen ratio is 1:2. Therefore name of this compound having the formula C7H14 is heptene. Now when the number of carbons are 8, what will be the general formula? C8, 2 times 8 is 16. Since the number of carbons are 8, the name is oct. And there is no middle name. And the end name is ene, because the carbon hydrogen ratio is 1:2. 8:16 and the ratio is 1:2. If the ratio is 1:2, that belongs to ene type. Therefore, name of the compound having the formula C8H16 is C8 is oct, ratio 1:2, therefore ene, therefore octene. If the number of carbons are 9, then the formula will be C9. What is 2 times 9? 18. Now, what is the starting name if the number of carbons are 9? It is non. And there is no middle name. And the end name is ene. You know why? Because the carbon hydrogen ratio is 1:2. Therefore, name of this compound will be non-ene. Non-ene. Then number of carbons are 10 in a hydrocarbon. Then the formula will be, that is in alkene, the number of hydrogen will be exactly 2 times of that. So C10H20. Since it is having 10 carbons, the starting name will be, dec. It will be dec, C10. So here it is C10, so it is dec. There is no middle name. The end name is ene, therefore the name will be decene. Okay, hope you understood how to derive the formula for the first 10 alkene compounds. Now, how to write the structural formula of the first 5 alkene compounds? See, before start writing any structural formula, we should always remember the valency of the carbon and hydrogen. See, the valency of carbon is 4, the valency of hydrogen is 1. So that means a carbon should have only 4 bonds surrounding it. A carbon should have only 4 bonds. It cannot have less, it cannot have more bonds than 4. Similarly, hydrogen can have only 1 bond. It cannot have more, because its valency is only 1. Now let us take the first 5 compounds. So when n is equal to 1, what is the formula of that alkene? C1H2. Okay, if you write carbon, the valency of carbons are 4. So 1, 2, 3, 4. How many hydrogens in this compound? Only 2. Okay, now these 2 valencies are vacant. These 2 valencies are not filled. Therefore, this compound cannot exist. Or if you put like this, C double bond H and double bond H, now you can say this compound can exist, because carbon is having two valencies here and 2 valencies here. Therefore, it is having 4 valencies. But what is the valency of hydrogen? Hydrogen valency is only 1. It cannot have 2. Similarly, for this hydrogen also, it cannot have 2. Therefore, this compound cannot exist. The valency of the carbon and hydrogens are not satisfied. Okay. Now, when the number of carbons are 2, what is the formula? C2H, 2 times 2 is 4. See, to write the structural formula of any alkene, like in alkane, first you write the carbons adjacent to each other. So connect these two carbons by means of a double bond. If there are more number of carbons, put only in one place a double bond. In all other places it should be connected by a single bond only. Here there are only 2 carbons, it is connected by a double bond. Now you count the valencies of the carbon. So 2 bonds are there, 2 valencies are satisfied. How many more required? 2 more required. For this carbon also 2 valencies are here, and now 2 more valencies are required. So 1 and 2. 2 valencies are required. Now fill all the valencies with hydrogen atom. So 1 hydrogen to this bond, 1 hydrogen to this bond, 1 hydrogen to this bond, and 1 hydrogen to this bond. Now if we count, so this carbon is there. How many hydrogens are bonded to this? CH2. 2 hydrogens are bonded to this, 1 and 2. So I have condensed and I have written it together. Now the double bond is there, so that I have written it here. I am writing right now here. And then this carbon here, and it is bonded to 2 more hydrogen atoms. So that also you can condense and you can write CH2 double bond CH2. So this is the formula of alkene, and this is a structural formula for that alkene having 2 carbon atoms. So now let us take, if the number of carbons are 3, let us take, if the number of carbons are 3. So write down all the 3 carbons side by side adjacent to each other. Put anywhere, either here or here, a double bond. In all other places you put a single bond. Now you satisfy the valency of carbon by counting the bonds. See, for example, you take this carbon, how many bond is there? Only 1. How many more required? 3 more required. So 1, 2, 3. For this carbon you take 1 here and 2 bonds are here. Therefore 3 valencies are satisfied. Only 1 left, so that we have to put 1 more bond to this carbon here, either down or up. Okay, here next one, take this carbon, so double bond. So 2 more valencies are required. So 1, 2. Now fill all the valencies with hydrogen. 1, 2, 3, 4, 5 and 6. See, we already know if the number of carbons are 3, if the number of carbons are 3, the number of hydrogen will be 6. So now you count here, how many hydrogens are there? 6 hydrogens are there. 1, 2, 3, 4, 5, 6 hydrogens are here. So therefore, if you condense this formula, what will you get? So you will get CH3 bond CH, then double bond CH2. Okay, so this is a condensed formula of alkene having 3 carbons, and here is a structural formula of the alkene having 3 carbons. Now can you write for 4? If the number of carbons are 4, what will be the formula? C4H8. So now put all the 4 carbons side by side. Put a double bond anywhere between any 2 carbon atoms. In all other places you put a single bond. Now count the valencies. See, for this carbon only 1 valency is there, so 3 more required. Fine. This carbon 2 valencies this side and 1 valency this side, 1 more required. And for this carbon 2 valencies are here and 1 is here, therefore 1 more required. For this carbon 1 is there and 3 more required. Okay, if you fill up the hydrogens, 1, 2, 3, it should be 8, no? 4, 5, 6, 7 and 8. See, C4, H10. So C4, H10 is a formula. Now 1, 2, 3, 4 carbons, and already we have counted 8 hydrogens. Now if you condense this formula, what will you get? CH3 bond CH. You just copy from there, that's it. Double bond, then C, it is bonded to only 1 hydrogen, then carbon, and it is bonded to 3 hydrogens, therefore CH3. So this is a condensed formula of an alkene having 4 carbons and this is a structural formula of the alkene having 4 carbons. If the number of carbons are 5, now what will you do? So first, what is the formula? C5, 2 times 5 is 10. So C5H10, 1, 2, 3, 4, 5. Put a double bond anywhere. In all the other place, you put a single bond. Now satisfy the valency of carbon by counting the number of bonds surrounding each and every carbon. So here only 1, so 3 more required. And for this carbon 2 are there, so 2 more required. Again for this carbon 1 plus 1, 2 are there, 2 more required. For this carbon 1 and 2 this side, 1 plus 2, 3 are there, and it requires 1 more, so you put 1 more. It can be down or up anywhere, but it should have only 1. Okay, now here for this carbon 2 bonds are there, how many more required? 2 more required. So now fill up the hydrogens. So it should be 10, no? So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, C5H10. If you condense this formula, what will you get? See here, this is the first carbon. It is surrounded by or bonded to 3 hydrogen atoms. Therefore, what will be the first one? CH3. And then put down this bond here. Now it is bonded to this carbon. You take that carbon, and it is bonded to how many hydrogens? 1, 2. Therefore, that will be CH2. Now this bond comes here. This bond between the 2 carbons comes here, and this carbon is there. Okay, this carbon bonded to how many hydrogens? 1 plus 1, 2, therefore CH2. Now this is connected to another carbon, and this carbon is bonded to how many hydrogens? Only 1, therefore you put only 1 hydrogen. Then double bond is there. Now the last carbon, it is bonded to how many hydrogens? 1 plus 1, 2, therefore CH2. CH2. So this is the condensed formula, and this is the structural formula of alkene having 5 carbon atoms. Hope you understood. You take your notebook and try to write yourself, and if you have not understood anything, come back and see it once again. So let us recap what we have learned. What is alkene? What is the general formula for alkene? Derive the formula for the first 10 compounds. What are the IUPAC rule to name alkene? How to derive the IUPAC name of the first 5 compounds? And how to write the structural formula of the first 5 alkene compounds. Okay, now let us see what is alkene. What is alkene? Alkene is a hydrocarbon, and the ratio between carbon and hydrogen should be 1:2. That is N should be N and 2N. That's it. This is a general formula. Second question. This is a general formula also. So CnH2n is a general formula for alkene. So alkene is a hydrocarbon in which the number of hydrogens are exactly 2 times that of carbon. Then what is the general formula for alkene? That is CnH2n. So derive the formula of the first 10 compounds. See, if the number of carbon is 1, then the formula will be C1H2. If the number of carbons are 2, C2, 2 times of 2 is 4. If the number of carbons are 3, it is C3H6. If the number of carbons are 4, it is C4H8. If the number of carbons are 5, it is C5H10. If the number of carbons are 6, 2 times 6 is 12. If the number of carbons are 7, C7H14. If the number of carbons are 8, it is number of hydrogens are 16. If the number of carbons are 9, then it is C9H18. If the number of carbons are 10, C10H20. So these are the first formula of first 10 compounds. Now what is the IUPAC rule to name alkene? See, we already have learned the starting name depends on number of carbons. The starting name depends on number of carbon. There is no middle name. The end name is ene. Then for IUPAC name, we have to write all the three combinedly. We already know if the number of carbons are 1, the starting name is meth. If the number of carbons are 2, it is eth. If the number of carbons are 3, then it is prop. If the number of carbons are 4, it is but. If the number of carbons are 5, it is pent. If the number of carbons are 6, it is hex. If the number of carbons are 7, it is hept. If the number of carbons are 8, then it is oct. If the number of carbons are 9, it is non. If the number of carbons are 10, it is dec. Now, what is the last one? Last but how to derive the IUPAC name of the first 5 compounds. Okay, it's so simple. The first compound we have taken CH2. I already told you it cannot exist, so let us forget about it. If the number of carbons are 2, C2H4, then the name will be ethene. If the number of carbons are 3, the formula will be C3H6, then that will be propene. If the number of carbons are 4, the formula will be C4H8, then the name will be butene. If the number of carbons are 5, the formula will be C5H10, the name will be pent. It will be pentene. Okay, now what's the last question? How to write the structural formula of the first 5 alkene compounds. Just now we have learned, so let us try to quickly redo it. So what is the first compound? CH2, it does not exist, therefore let us forget about it. What is the second compound? C2H4, you put carbon and carbon, connecting it by means of a double bond. Now put 2 more bonds to each carbon so that the valency of the carbon is 4. That is, each carbon should be surrounded by 4 bonds. Fill all those bonds with hydrogen. That will be the structural formula of the alkene. Now if you take the next compound C3H6, how many carbons are there? 3 carbons. Put them side by side. Put a double bond between any 2 carbon atom. Between the other 2 carbon atom, put a single bond. Again count the valency and make it 4. See, for this carbon 1, so it requires 3 more. And for this carbon 1 plus 2, 3 are there, so it requires 1 more. And here it is 2 are there and it requires 2 more. So fill all those bonds with hydrogen. 1, 2, 3, 4, 5, 6. Okay, now you are getting the formula C3H6. Now what is the structural formula of C4H10? C4H8, exactly 2 times. So put 4 bonds, 1, 2, 3, 4. Put a double bond anywhere and all other places put a single bond. Now count the number of bonds surrounding each carbon and make it 4. For this carbon only 1, so 3 more required. And for this carbon 1 plus 1, 2, so 2 more required. And for this carbon 1 plus 2, 3 are there. So here 1, here 2, 3 are there. So it requires 1 more. And here this carbon 2 bonds are there. It requires 2 more. Fill all these bonds with hydrogen. 1, 2, it should be totally 8. 3, 4, 5, 6, 7 and 8. So this is the structural formula for C4H8. So what's the structural formula for C5? What is exactly double the number of carbons? 10. C5H10. So how will you write this one? 1, 2, 3, 4, 5. That is, put down the carbon side by side by connecting by means of single bond, except in one place. In any one of those places you put a double bond. Anywhere. The double bond can be anywhere between any 2 carbon atoms. So let us see here. All other places you put a single bond. Now, so count the valencies and make it 4. So here only 1 bond is there, so 3 more required. And for this carbon 1 plus 1, 2 are there, 2 more required. For this carbon 1 and 2 this side, so totally 3, 1 more required. For this carbon 2 plus 1, 3 are there, 1 more required. For this carbon only 1 is there, so it requires 3 more. Now fill all the bonds with hydrogen. That should be totally 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, these are the structural formula of the first 5 alkene compounds. That's it for the day. Hope you understood. Thanks for listening.